Alright, so yesterday we were looking at this implicit differentiation a little bit further. Okay, finding the derivative of an equation with x's and y's mixed in. Alright, so on page 204, we're working on this box on the right-hand side. It says, given this curve, find whatever this means. What does that mean again? Second derivative. Okay, so we're going to go 2 rounds of a derivative. Let's go the first round. So working our way left to right, the derivative of x squared we know is 2x. Then we have to add the derivative of y squared, which would be, we're whispering it, yep, 2y dy over dx, good, equals 0, good, okay, don't write 1, you need the derivative of 1. Alright, let's clean it up. We're going to get dy over dx all by itself, so maybe subtract the 2x and divide over the 2y. The 2's would cancel, so we're left with negative x over y. That's the first derivative. They wanted us to find the second. Okay, so we have to go another round. If the first derivative is negative x over y, what shortcut do you want to use to figure out the second derivative? Quotient, right, we have a fraction, so we need low, and then d high, the derivative of negative x, we got negative 1, minus high, and then we need d low, the derivative of y, dy over dx, good, all over the bottom squared. So we'd have y squared. So far so good? Okay, we're going to simplify it a little bit. Y times negative 1, we can have negative y. If we are subtracting a negative x, we can change that to a plus. Now, we have a dy over dx symbol right there, but that's just signifying the first derivative. Do we know what the first derivative is? Yeah, that's right here. So instead of writing dy over dx, let's go ahead and substitute in the first derivative that we found. And that's all over y squared. Alright, one last thing that you can do if you wanted to, you could actually multiply x times this fraction. Okay, the x would move to the numerator, so it would make it a x squared up there. Alright, but I'd say you could leave it like that. That's pretty good. We could keep going. We do have fractions galore, so you could use some fraction properties, but we'll stop there. We doing okay? Alright, so what we're going to do for the majority of today, actually the rest of today, is take a look at a free response question. Okay, I think I told you guys eventually I'm going to give you some of these to try on your own, okay, or not by yourself, but with a partner or in a group, okay, to kind of talk through them. But we're going to start to get used to the format and the wording that these free response AP questions kind of look like. So this was actually taken from the 2008 exam. Okay, this was on the actual test. And I want you to get used to kind of the expectation, the wording, trying to see how you would do or how you would fare right now if this was actually on it. So try to see how well you could have done. When we get done with this, I'll show you where the different point values were located, like how it would have been graded, so you can see how you would have done. Okay, so take a look at the directions. It says consider the closed curve on a coordinate system given by this equation. So it's just some closed shape. We don't really know what it looks like. So part A, show that dy over dx, meaning the derivative, is this result. So mathematically, you're going to have to show every single step of your work. They're giving you the original equation, the original curve, and you need to show how you get this in the end as your derivative. So let's go ahead and start this off. Taking the derivative one thing at a time. The derivative of x squared. We got 2x. Do you guys want to try this one on your own? See how you would do? I'll give you a few minutes. You try it first. Okay? What's nice about this question is you already know what the answer should look like in the end. Okay? So take your time, check your work. This is what you're trying to get. See if you can do it. Alright, so before we check this one, there's just a few things I wanted to mention about the free response questions on an AP test. Each free response question is worth 9 points, okay, every single one. How those points are distributed or weighted is completely random, depending on the difficulty and type of question. So for instance, part A might only be worth 2 points, whereas part D might be worth 3 points. Part B might only be worth 1 point. Okay, so the distribution is a little bit different each time depending on the question, but each free response is totaling 9 points in the end. A good score on a free response question is like a 4 or a 5 or better. Okay, so if you can get half of the points, that's good. Okay, and if you've noticed, at least in the free response questions that you guys have done in here, like where you have to justify and do all that good stuff, you guys do pretty good. Okay, so don't feel too stressed out about these. Okay, a 4 or 5 is always a good score on a free response question. Okay, in total. The other thing is the AP people give you an average of 15 minutes per free response question. But you'll normally get about 3 of these. You know, we have taken the SAT before, right? Or some type of standardized test. You know how they'll give you like 50 minutes for a section. Okay? Typically, they'll give you 3 free response questions, which means you'll have 45 minutes to do the 3 of them. You don't have to spend 15 minutes on each one. You could spend 5, or you could spend 10 minutes on one and then 20 minutes on another. And notice how that averages to 15. Okay? So in terms of budgeting your time, try to think about 15 minutes per question. Okay, if you can do it in less time, that's good, because that means you have more time to spend on another one. Okay, so about 15 minutes per question. Those are the 2 big things. Okay, the point values and the timing. Any takers? Want to try part A? What'd you do? Go ahead, Dan.
I got 2x plus 2 plus 4y cubed dy over dx plus 4 dy over dx equals 0.
Okay. How many of you had that written on your paper? You would get 1 point just for that. Okay? Do you want to keep going, Dan? Where'd you go from there? Okay.
I moved the 2x and 2 to the right, so it reads as 4y cubed dy over dx plus 4 dy over dx equals negative 2x minus 2.
Okay, did we do that? Did we get all the dy's, dx's on one side, everything else on the other? Okay, unfortunately that would not get you a point, but that is something you have to do in order to get here. Okay, if you want to keep going, Dan.
Yes, then you take the dy and dx out of the 4y cubed plus 4 to get dy over dx times the parentheses 4y, yep, that, and then...
Okay, good, okay. You want to keep going?
Yes.
Okay.
And I divided the right by the left bracket, which was 2x minus 2 over 4y cubed.
Okay.
Plus 4. Then I had an equal sign next to that and took negative 2 and had the quantity x plus 1, and then under it 4 quantity y cubed plus 1.
Okay.
And then next to that I had the reduced form, which is negative x plus 1 over 2 y cubed plus 1, which is the initial thing at the top.
There we go. How many of you were able to show the factoring, okay, taking out the negative 2 and the 4 and then having your final result? Could we do that? Okay, if you had it, give yourself another point. Okay, that question was worth 2. They give you a point for the initial derivative, okay? And unfortunately, all the work you have to do through there doesn't get you anything, but if your work is correct and leads to the result that they want, then you get that point. Okay? We doing okay? Awesome. All right, let's check out part B. So you might not be able to see it on the board, but it's on your paper, okay? Write the equation of the line tangent to the curve at that point. Do you guys want to try this one on your own? The equation of a line, what do you need to know? Yeah?
Derivatives and the points.
Okay, you need a point and a slope, aka a derivative. Do we know the point?
Yes.
Yes.
2, comma 1.
Do we know a derivative?
Yes.
Yes. Okay, so this is something I want to point out to you. Notice how, even if you got the derivative wrong in part A, okay, they give you the exact derivative up here. You realize that, okay? So even though this might be incorrect, okay, you can still perform part B because they give you the correct derivative, okay? So how might we use this derivative up here to figure out the slope value needed for our tangent line? Yeah?
Plug in the x and y values.
We're going to plug in the x and the y from the point. Okay, so we would have negative 2 plus 1
over 2, 1 cubed plus 1.
1 cubed plus 1. Good.
Should become 1/4.
Mm-hmm. Okay. So in terms of point values, if you were able to get 1/4, they would give you a point for that. If you could realize you had to plug in the point into the derivative to get the slope, which we've been doing all year, you would get that point. Now that you know the point and the slope, what would your equation look like? Yeah.
Y minus 1 equals 1/4 x plus 2.
X plus 2. If you can write that equation, you would get another point.
What did you say was a good amount of points again on these?
4 or 5.
And what's the max that you can get?
9.
9.
9. Yep. Okay? We're doing okay so far. Notice how you have 4 points. Okay, you're already at a good score. Okay, we can just keep making it better. Here's another thing. Okay, let's say that your slope was incorrect. Maybe you got like -3, and you wrote your equation with the -3 in there. They would still give you this point because you technically wrote the equation of a tangent line correctly. You just would not get this point. Does that make sense? Okay, so even though your slope was incorrect, you still used it correctly to get this result. So they're not going to penalize you twice. Okay? Let's go ahead and check out part C. Find the coordinates of the 2 points on the curve where the line tangent to the curve is vertical. How do you want to set that one up? Stevie?
Bottom equal to 0.
Bottom is 0. Okay, bottom of the derivative is 0. So take a look at part A where they give you the exact derivative. We're going to set the bottom equal to 0. Can we solve for y? Go ahead, Dan.
Yeah, so if you distribute the 2 and get 2y cubed plus 2, then you can move that 2 to the right to get 2y cubed equals -2.
-2, okay.
Divide by 2 to get y cubed equals -1.
All right.
And then cube roots, y equals -1.
Cube root. Okay, so you can take cube roots of negative values.
However,
Square roots, no.
I do have,
Uh-huh.
it says 2 coordinates, but we only got a y.
Okay, so here's the
Which is where
question.
I got stopped at.
If you could get -1, give yourself a point. All right, so the question is find the coordinates. What does coordinate mean? Yeah.
X and y.
X and y. Okay, you need an ordered pair. If you know a y value, how can you figure out an x value? Yeah. Plug it into the original equation. Okay, we don't want to plug it into the derivative because derivative means slope, right? We're not trying to figure out a slope, we're trying to figure out a point, a coordinate. So but using the original curve equation at the top, we're going to plug in -1 for the y values. Which means we should be able to solve for the x's. So x squared plus 2x plus 1 minus 4 equals 5. How do you feel like solving for these x values? Is there something in there that's kind of cluing you in to a technique or something? Yeah.
You can move the 5 over and get a x squared plus 2x plus 8, I believe is what that adds up to. 0.
Equals 0.
Factor.
Let's factor. All right, we have a quadratic, we have an x squared in there, so we'll set the equation equal to 0 to factor. 2 numbers that multiply to 8 but add to, or it should be -8, I think. 2 numbers that multiply to -8 but add to 2. -2 and 4. So the x coordinates would be 2 and -4, right? So now that we have the y value and some x values, let's write those 2 points. So one point would be 2, -1, and the other point would be -4, -1. You have 2 different x values but the same y value. If you could get both of those ordered pairs, you would get a point. All right, now unfortunately, this is what kind of trips some students up. Let's say you had one of them correct, but the other one incorrect. You would lose that point. Okay, you would have to have both of them written correctly in order to gain that. So it gets a little tricky when there's multiple things you need to have and it's only worth 1 point. You need to have all of those pieces. So just be sure that you're kind of consistent and clear on how you write things. Okay, let's go ahead and check out D, the last part. Is it possible for this curve to have a horizontal tangent at points where it intersects the x-axis? Thank you. What do you guys feel like doing? Can we list anything that might be worth noting? Can we decipher some of those phrases into some things that we're more familiar with saying? Yeah.
Well, we'd have to know that dy would have to be 0.
Okay. So horizontal tangent means flat line, aka slope of 0. And in terms of our derivative, the top would have to be 0. Right? Yeah.
Y also must be 0, as it's intersecting the x-axis.
Okay, so let's take a look at that wording at the top. So horizontal tangent means the derivative is 0. Since our derivative is a fraction, okay, the top would have to be 0. They go on to say where it intersects the x-axis, okay, aka x-intercepts. So if you think about x-intercepts, okay, they all have different x values because they're located at different spots, but all of the y values are always 0 for those x-intercepts. So those are two things probably worth noting. Let's start with the first one. Can we figure out when the top of our derivative is 0? Good, Dan?
When it is -1.
All right, so let's go ahead and take the top of that derivative, set it equal to 0. We would get -1. If you could figure that out, you would get a point. All right, I seem to be running out of room, so I'm going to erase a little bit here. Hopefully you guys have been writing a little bit smaller than what I have. Okay, let's see. Is it possible, so this is like a yes or no question, is it possible for this curve to have a horizontal tangent where it intersects the x-axis? Where do you want to go from there? Where do you want to try, Dan?
Oh, I thought I meant 2 points. Okay, so where it intersects the x-axis, well, we know that x has to equal -1.
Mm-hmm.
We need to determine if dy is 0 at x, -1, and y is 0 in order to prove that at that point it would reach that.
All right, so how do you want to do that?
By taking the derivative, you can plug in -1 plus 1 all over 2y squared, which would be 0 cubed plus 1, and find out if that equals 0.
It does equal 0, right?
Which is true, yes.
But how do you know you are on the x-axis there? You had a y value of 0, which is part of it. What do you want to do, Justin? Hold on. What do you want to do, Justin?
Go to the original and plug in 0 for y, and then see if one of your x values coming out of that would be -1.
You could do that, okay? So we know an x value is -1. You could plug that in at the top and see if one of your y values is 0. You could plug in 0 at the top for the y's and see if one of your x values is -1. We got to check to see that this is true, but that is also true at the same time. Something else you could do is we could plug in -1 for all the x's and 0 for all the y's and see if we get a true statement. Okay, for instance, if you take a look at the top, if you plug in -1 for all of your x's and 0 for all of your y's, does it actually equal 5? Okay, so there, you have multiple ways of checking this. Okay, it's just a yes or no answer. So if we simplify, we have 1 minus 2 plus 0 equals 5. Does negative 1 equal 5? No. All right. So let's explain our reasoning. Let's think about this. We started off by showing how the derivative or the slope is 0, okay, at negative 1. This is the only point, the only spot on the curve where you can draw a horizontal tangent line. But what we did is we checked this x value in the equation with the y value of 0 that it should have if it's on the x-axis. But notice how we're not getting a true statement. So this x-coordinate of negative 1 does not have a y value of 0, meaning it's not on the x-axis. Okay, so we'll say no because x equals negative 1 is the only horizontal tangent location but, okay, the point negative 1 comma 0, okay, the x and y that we checked in the original equation is not an x-intercept. All right, so here's where the point values would have fared for this one. I already said if you were able to get negative 1, you would get a point. If you showed somehow that you got a false statement or that 0 or negative 1 were not the right locations like Justin was referencing, you would get a point for that. And you would get another point for your justification. Okay, you would have to say no, but you would also have to give a valid reason why. Okay, so if you add all those up, that should be 9. Okay, so if you think about it, take a look back at the questions. Think about if you were to do this, okay, without looking at your notes or talking it through how you would have done. Remember, a 4 and a 5 or more than that is always a good score. Okay? Okay, we're going to do a lot more of those throughout the year. Okay, getting used to wording, point values, okay, expectations, all that stuff. All right, that's it for today. We still have about 10 minutes left if you guys want to start some or try some homework problems. We're going to start the next section next week. Okay?